Hello everyone, welcome back. So this is a continuation from where we ended. So this is now B5 of Chemistry Revision 2017 past paper. Alright, so before we get to it, don't forget to like and subscribe to the channel. Alright, so the question reads, chlorine, bromine and iodine are elements in group 7 of the periodic table. The first question states that we need to describe the change in states of elements at room temperature and pressure, which is RTP, as the atomic number increases. So as the atomic number increases, what you need to know is that the states of matter changes from gas to liquid, then to solid. So that's what happens when the atomic number increases. So when the atomic number increases, basically the states of matter changes from gas to liquid, then to solid. And this is just the opposite if the atomic number decreases. So if whatever question that you come across where they just say describe the change in the state of the elements at RTP when the atomic number increases. So as the atomic number increases, the states of matter changes from gas to liquid and then to solid. If the atomic number was decreasing, then the states of matter will change from a solid to liquid and then to a gas. The second question says, why is chlorine used in water treatment? So chlorine is used in water treatment basically to kill bacteria. I feel like this is just a general knowledge question. Alright, so B says, write an ionic equation for the reaction between chlorine and aqueous potassium bromide solution. So this means that the potassium bromide was dissolved in water, so it's basically now a solution. Include state symbols. Okay, so potassium bromide, for you to know how this compound will be written, potassium bromide, just go to your periodic table and quickly look for the two elements. Look for potassium, which is K, and bromine, which is B small letter R, like that. Then after that, all you have to do is to check for their valencies. Remember, the valency is known by the group in which the particular element belongs in. Potassium is in group 1, so it has a valency of 1. Bromine or bromine to be precise, is in group 7, so 8 minus 7, you also get a 1. You do a crisscross, you get K, B, R. So this is how it's going to be. Then we're trying to look at it reacting with chlorine. Now chlorine is a gas. So remember, in chemistry, every time you have a gas, you put a 2. Always. So whatever it is, hydrogen gas, then it's H2. Chlorine gas, Cl2. Whatever, as long as it's something, then they say gas, just put 2 as a subscript, like that. Alright, so with that in mind, we can now write our equation. So it's going to be K, B, R. Remember, this is solution, so it's aqueous. Then reacting with chlorine, it's a gas, we put a 2, gas state. Now what will happen is that potassium, once it reacts with chlorine, it will form potassium chloride. For you to know how the potassium chloride will be made, you do the same thing, you do a crisscross. Yeah, potassium is in group 1, chlorine is in group 7, so if you do a crisscross with the valencies, you still just get KCl. It's so funny, it almost sounded like ACL, but anyway, KCl. So you get KCl, then you have the bromine, like that. It's a gas, so you put a 2. Oh no, not really. So that. Now look, since this is aqueous, it won't really be a gas. If potassium reacts with chlorine, okay, so chlorine would displace that and you get bromine. All right, so it's going to be liquid, not um, not gas. Then this will be aqueous. So we need to balance this. We can use the traditional method, which is a guess and check method, but we also have the algebra method. Let's just use the guess and check method. Remember, the number of atoms on your left should be equal to the number of atoms on your right. You have the number of potassium atoms on your left to be 1. The other side you have 1. Then bromine, you have 1. This side you have 2. So let's increase the number. Let's put a 2 there. So you have 2 potassium. So put a 2 there. So you get 2, 2. Balance the potassium. Bromine, you have 2, 2. 2 that side. Balances out. Chlorine, because of this 2, you have a 2 there. Then this 2 here, there. So it's balanced. Then all you have to do is just separate those that are in aqueous. So this would be simply 2K plus 2Br plus Cl2 gas producing 2K plus 2Cl in aqueous. So this will be in aqueous. This is just a rough way of doing it. Yeah, so this would be in liquid, so I'm going to temper with it. So this guy will just cancel with the other one there. So basically these 2 will go to the bottom and you have 2Br. This will be your final stage after you do all the cancelling. So you have 2Br. Bromine is a non-metal, so you have a minus there. So this will be aqueous plus chlorine. Since it's a gas, no need of putting the charge. Then you have 2Cl. Then minus chlorine is not a metal. Aqueous plus Br sub 2, which is a liquid. No need of a charge. So this is the final answer once you do your ionic equation. So that's how you go about solving this question. Alright, thanks for watching. Let's move on to B6. Remember to like and subscribe.